Hi everyone, welcome back to TechVidyalaya. Today we are going to learn one of the most important sorting algorithm, that is bubble sort. So today what we will learn. So first we will learn how bubble sort exactly works, why this is called as a bubble sort. Then we will implement it in Java. Okay. So what exactly is sorting? Sorting is nothing, just arranging the data in a particular order. It can be ascending order or it can be descending order. Okay, so if you see, I'll take an example 51428. If you compare this array is unsorted, right? So to make it sorted, I can do like this 1 2 4 5 8. So now this is sorted. So to convert this unsorted array to sorted array, we have a different algorithms. Okay, so one of the simplest way to make it is bubble sort. Okay, why this is called bubble sort? If you imagine bubbles in the water, what happens? The lighter bubbles slowly rise to the top, right? So similarly, in the bubble sort, the largest element slowly moves toward the end, just like the bubbles rising. So first what we will do, I will take an array and for the each pass we will see how the sorting works. Okay, so this is our unsorted array, right? So in the pass one what happens? So what we will do, we'll take one element, we'll compare with the adjacent element. If it is less than, okay, after comparison, we'll make a swap of these elements, okay. So first what we will do, we'll compare 5 and 1. You can see 5 is greater than 1, right? So what we will do, we'll make a swap. After making it swap, what will be the value? 1, 5, 4, 2, 8. Okay. So now what we will do? We'll make a comparison between 5 and 4. So you can see the 4 is less than 5. So what we will do? We'll make a swap. 1, 4, 5, 2, 8. Similarly, we'll compare 5 and 2. Yes. Then we need to do also swap. 1, 4, 2, 5, 8. Now you can see similarly what we need to do, 5 and 8. You can see the 8 is the largest element and it is in the correct position, right? And 5 is also in the correct position. So no need to do the swap. We can write it. Okay. This is the pass 1. Next we'll do for pass 2. So for the pass 2, what we will do? We'll compare. The element will be started like this. 1, 4, 2, 5, 8. Okay. Now we'll compare 4. Sorry. We'll compare with 1 and 4. You can see 1 and 4 is already sorted, right? So we'll write it. Okay. No elements will be required. So next we will do 4 and 2. Yes, the swap needed. Then what will happen? 1, 2, 4, 5, 8. Then again, the similarly, what we will compare? 4 and 5, right? So 4 and 5. 4 and 5 is also already sorted, so we'll make it. Okay. So this part is already sorted, so we don't have to worry about that one. Okay. Next is pass 3. So in the pass 3, our elements will be like this: 1, 2, 4, 5, 8. Similarly, we'll compare 1 and 2. It's okay. Then 2 and 4. This is also okay. Then 4 and 5. This is also okay. So this part is already sorted. Then we will move to the next one. This pass will continue until the whole array is sorted one. Okay. So this exactly how the bubble sort works. So for this algorithm logic, what we need, so we have to make two loops. One is outer loop for the number of passes and then the inner loop. For the inner loop, what we will do, we'll compare the adjacent element, then we will swap it. if needed. Okay, so let's do the Java implementation for this one. So now we will do the Java implementation for this bubble sort. Okay, so for this what we need numbers, array of numbers, right? So for this we will take one variable, integer array nums, and we'll keep some variables over here. 5 1 will keep the same variables whatever we have taken earlier. Okay, so to wait, then what we will do, we'll print the numbers before sorting, then we'll print the numbers after sorting. Okay, so system dot out dot, this is for before sorting. Then we'll iterate over the array nums, print it will not keep ln because it will print then again line by line, right? So nums will keep on space to make it more clear. Similarly, we'll print it after sorting, right? So this is before sorting and this is after sorting. In between what we will keep? We'll keep the sorting logic. Okay, if we print it now, so what will happen if we print it now? You will see there is no changes. You will keep one extra line. If we print it now, we'll see there is no changes in the before sorting and after sorting. Okay, you can see there is no changes. So what we understood that in the bubble sort theory classes, we understood that we need two loops, one outer loop for number of passes, then one inner loop to compare the adjacent element and for swapping, right? So for outer loop and I equal to 0, we'll start from here, then nums length minus 1, then we'll do a increment for this one, right? Similarly, we'll start from here, okay? Now after running each loop, what we need to do, we need to compare the adjacent element, right? So if nums of j is greater than nums of j plus 1, if this is the condition, then do a swap for this one, right? So for swapping, we need one temporary variable in nums j, nums of j plus, then we'll store it in the temp. Okay, so that's the logic for the swapping. So what we did, we have created one outer loop. If I comment it down, then the outer loop for number of passes, then one inner loop for comparing adjacent element, then here we will do the comparison, then we will swap it. Now if we save it and we will rerun this one, we can see that our array is sorted. But there is one problem over here. If you see, if I print it after each passes, Okay, after each passes, you will see one issue over here. One second. We'll write it pass and we'll print the I. Okay, yes. If you see here that each passes, suppose the first pass is gone, right? So already this 5 8 is already sorted. Again, there is 4 5 8 is already sorted. So no need to go for those sorting elements, right? Because the largest element will be moved to the towards the end. So no need to go for that one. So for that case, what we can do when we compare the inner loop, when we run the inner loop for comparing the adjacent element, we'll skip those elements, we'll do minus I, so that whatever the elements, whatever the number of passes, suppose here pass 1 is gone, so pass 1 means the next time the 8 will be ignored because we assume the 8 is already sorted. So in here we will see no changes, but in runtime the efficiency will be little more on that. Okay, so you see there is no changes, but yes, the efficiency is little more better right now. So if we come to the time complexity of this bubble sort, then best will be O of n if the array is already sorted, and the average will be O of n square, and in worst case also O of n square. So that's why the bubble sort is mainly used for learning, not for the big data. Okay, so that's it for the bubble sort. Thank you.